Fiction and reality. New stories, new ideas. Little Beth Entertainment.
Welcome to Season 6, Episode 95 of The Rocketry Show at TheRocketryShow.com. We've got a great one in store for you here. We're talking to Gary Rosenfield of Aerotech. We're going to be talking about high-power rocket motors and rocketry in general. So stick around. The Rocketry Show starts right after this.
Going up in 5, 4, 3, 2, 1, liftoff.
From Little Beth Media, a new podcast on model rocketry, with build techniques, model rocket history, interviews with industry insiders, stuff for beginners and longtime model rocketeers, everything from low to mid-power. The Model Rocket Show, with me, the Rocket Noob, at TheRocketryShow.com or anywhere you download podcasts.
The Rocketry Show would like to thank the following patrons for their support: Phil Bridges, Mark, Roy Tyson, Rob Haji, Gary Dow, Jay Foman, Don J, G. Smearden, M. Erzman, Pierre Malo, Jeff Curtis, Timothy Mock, Jeff Curtis, Brian Lapato, Jay Bryan, Casey Anderson, Terry Dancer, Mark Eswine, Jim Wilson, and Jason O'Scully. If you wish to show your support and become a patron of The Rocketry Show, just visit us at patreon.com/The Rocketry Show.
Ignition sequence start. 6, 5, 4, 3, 2, 1, 0. All engine running.
Welcome to The Rocketry Show.
All right, liftoff and the clock is started. Yes, sir. Reading loud and clear.
A podcast that is all about advanced and high-power rocketry. Amateur-built rockets, starting at mid-power to higher-power versions. This program is hosted by the team who loves the smell of burning rocket propellant in the morning. Here are CG, Gene, and model rocket guy, Jesse Yu.
Welcome back to The Rocketry Show at TheRocketryShow.com. I'm CG.
And I'm Jesse, Model Rocket Guy.
And Gene is also part of the show, but he's not around because he's on a camping trip with his kid, trying to make the best of this COVID summer that he can. So you'll hear him in a couple of minutes as we talk to Mr. Gary Rosenfield from Aerotech.
Indeed.
And this is a great show. And before I get started, just in case you're kind of new to high-power rockets and all that, we're going to be getting into a discussion on some of the new things that Aerotech has going on. And we're going to be tossing around terms that high-power people just routinely fling around when we're in the field. And we did that on this episode. So I thought I'd take a quick moment before we jump into the interview and just kind of define some of the things we were talking about. So one of the first things you hear us just casually toss around is the term CATO. And just in case you don't know what that is, I figure we'll go and talk about that. Now, the CATO has several different meanings. And the most common meaning that you hear, if somebody would ask us what it means, would be catastrophe at takeoff. And you will see that happen from time to time more. Well, you do see it with low power rockets. Some of the E-motors, the black powder E-motors, are prone to doing that.
Infamous motors, E9s and E12s. Yep.
When you light the rocket and either it goes pop when the nozzle pops out and the whole thing just becomes uneventful at that point, or it might explode or something like that. And in high power rockets, that can happen if you do something wrong or if there is an actual structural failure, which doesn't really happen very often. Typically, it's because somebody did something wrong and
installed an O-ring improperly, or the assembly wasn't quite tight enough, let some gases escape. Yeah.
Yes. And some of those are quite spectacular. So when we talk about CATOs, that's what we're talking about. Jesse, what's another term you've heard tossed around for meaning of CATO? Do you know any?
Basically they just call CATO just a short for just catastrophic failure. So, I mean, it is a catastrophic failure on takeoff. But when they say CATO, they just referenced it to that. That's about the only other time I've seen it.
Because an unplanned rapid disassembly of your rocket.
And I've unfortunately had that happen to me a few times. You hate to see it. You hate to be the one that does it, but you're going to be one of the first ones there at the fire extinguisher, hopefully, if it does. So
yes.
make sure you help out your clubs that way.
Yeah, I had that happen once. Oof. Anyway, and the next thing we're going to toss around on the show,
the motor terms. Yeah.
Yeah. So there's long burn motors, and or they also could call them moon burners as well. And those are the rockets where you light the engine and it just keeps going and going and going and going. A lot of high power rocket motors have a thrust that's maybe like anywhere from 1 to 3, maybe 4 seconds on average. Mostly they're around 2 seconds or so, 2 to 3 seconds. But then you get the long burn ones where the flame will go for 6, 7. And you hear about some motors where it's up to 20 seconds during this episode. And the trick with those is that they don't dump out a lot of impulse right away. That the impulse happens over the course of that 20 seconds. So you have to have rockets that are specifically designed to handle those motors, so you don't end up becoming a land shark or weathercocking in some weird, bizarre way.
So it's kind of funny that we mentioned the long burn motors, because the motor that I want to use from level 3 is kind of a long burn motor, but it's not. It's 7 seconds. But count to 7. Count to 7, guys, and it's a long time. So it's a lot of money to burn per second, right? But my wife was talking about it the other day. She's like, "How long will that thing be in the air?" Well, it's got a long burn motor, so the actual burn time is going to be 7 seconds. So then I made her count out 7 seconds. She's like, "Yeah, that's a long time." And I'm like, "That's when you actually see the smoke, and then after that, it's going to coast for however many feet."
Right.
So yeah, I'm excited to see that. But long burn motors are really cool. And we've got a lot of Rocketeers in our groups that fly those, and they're impressive. Very impressive.
Yeah, I love that heart in the throat moment when I used to do this all the time with the E9s because they have like a good 6 second burn time.
Oh yeah, definitely.
So you light them and the motor is still burning and you can't see the rocket anymore, but you still hear the motor going. It's like, oh, I hope I can find it after this. So,
right.
Get
a small tracker.
Yeah, exactly. So that's a long burn. Go ahead. Yeah.
No. One of the ones that they were talking about, CG, and maybe you can explain this to me because I'm a little new to this too. What is a core burner then?
Yes, that's another term. Okay, there's core burner motors and end burner motors.
End burner, okay.
Okay, end burner motors, I'll start with that one. Like a black powder motor is an end burner motor. So when you light the motor, it starts at one end and the propellant burns from bottom to from the ignition point all the way up to the top. A core burner is like most of your composite motors where there's a slot cut in the grain. And when you light the propellant, the core burner motors, the full length of the propellant burns, but it starts in the middle and burns its way out towards the liner.
Okay.
So yeah. So
everybody's kind of dealt with these motors to begin with, but now we know the terms for them. So see, and once again, I don't claim to know everything. So thanks for clearing that up, CG. That makes a lot of sense now.
Right. And there's a lot more to the physics behind an end burner and a core burner and why you would want to have one or the other. But we'll save that for another show when I can have guests on that are better at explaining motor physics than I am. So
yeah, no, I feel you. But no, that's good. I mean, see, and we all need to have these small conversations to find out the things that we don't know.
Right.
But yeah, I mean, we deal with these motors every time. I mean, every time you do a reload, that's going to be a core burner then, right? Mm-hmm. And every time you do a black powder motor, that's going to be an end burner. That makes perfect sense. All right.
And there are some composite motors that are end burners as well. And that's something I learned. I mean, I haven't delved that deeply into composites because I have my favorite motors that I fly. And I'm not really focused on the motors myself. I'm focused more on my projects on the rocket. So it's either the rocket design or my electronics. So I just pick a motor I like and know, and I just stick with it. But I haven't gone into this experimental thing. But after this episode with Gary Rosenfield, I find there's motors that have characteristics of both, and they're pretty cool. So it's like, hey, okay.
So did you start looking at Aerotech motors after the interview with Gary? Because I totally did. After we were done, I pulled out my phone and I started looking at some of the vendors that we have, and started comparing motors. I'm like, oh, look at this.
You know what I'm going to do? Stuff. What I'm going to do is ask me that question after this interview is over. Because I want to definitely jump over and not delay this much longer for folks. But I want to get that out of the way. But we could talk more about that because, yes, I do have experiences like you said. So anyway, with that in mind, let's shut up now and get right to the Gary Rosenfield interview right here on The Rocketry Show at TheRocketryShow.com. Enjoy. Welcome back to The Rocketry Show at TheRocketryShow.com. And we are joined with Mr. Gary Rosenfield of Aerotech. And we're going to be talking about the new motors and new projects that Aerotech has been working on for the high-power rocketry and a lot of cool stuff. Welcome to the show, Gary.
Thanks, Cornelius. How you doing?
I'm doing A-OK. How about you? How are you hanging in there?
Just fine. Had a very busy day today. It was nice to come home and relax, but tomorrow we'll hit it again.
There you go. Very good.
Busy is good these days, right?
Yes.
Yeah, we're just trying to keep busy, and we found that, we don't want to slow down the R&D process or relax. We just want to keep pushing ahead with new products and new technology and new ideas. And we were discussing a lot of that today.
Yeah, like from your Facebook pages and from all that, it looks like you guys are doing a lot of stuff. So, I mean, just to toss out a general question to start off with, like, what are you working on?
Just all over the map. I mean, we're working on long burn motors, and we're doing some advertising stuff and marketing things, and we're trying to come up with a decal sheet right now that it's got everything on it. It's got Quest, Aerotech, Enerjet, even industrial solid propulsion and RCS on there.
Kind of like a master list, huh?
Yeah.
So what kind of long burn motors are you able to talk about so far? I'm a big fan of long burn motors, by the way. So.
Okay. Well, we had talked about this H13 that I used last year for the Hamster Dance contest. And
right.
When we tested it for temperature, it was getting over 500, like 550, 560 degrees Fahrenheit. And,
on the outside?
Yeah, on the outside,
okay.
Which is way above the temperature that's allowed under NFPA code. So we couldn't get it certified. But, we sold a bunch of them to movie producers and other experimenters that could legally get them, outside of Tripoli and NAR and all that. But we had to come up with a technical solution to try to drop the temperature. So we thinned the case and we thickened the liner, and then the NAR has a protocol. The way they test the motors, you put a thermocouple near the nozzle and a thermocouple about 3/4 of the way down, and you average the temperature. So by doing that, and if Tripoli agrees to that, then we found that with the new design, we got an average temperature of about 270 degrees Fahrenheit, which will pass.
Like, what is the burn time on that H? It's got to be like 19 seconds or something? Something crazy?
It depends on the temperature, the ambient temperature, but it's around 16 to 17 seconds.
Jeez.
Oh, wow.
Yeah.
Nice.
Yeah. And I flew that last year at the contest, got over 13,000 feet with it. So pretty amazing.
I mean, even with the long burn G8 that I tinkered around with a little bit when I was doing that, we were talking a little bit on the show before we got started about the thrust vectoring that's going on with Joe Barnard and how it's taking off literally with some other folks. And, I was just asking about the availability of the G8 might be coming soon. I mean, I know that they're available going through some educational and research type protocols, but to have it open to just the average user would be something really good, because that's like, it's not a crazy motor, but it's a really long burn motor. It's like a 12-second burn, I think, on it or something like that. And for thrust vectoring, it's really cool. So if you want to have a finless rocket and you have a flight computer that can thrust, vector your fin, you don't need fins. So, and that's a project that there's quite a lot of that's going on. And I imagine that the long burn motors would be in demand for that, because I see on Twitter there's like all these, besides Joe, there's like 5 or 6 other groups that are starting to do this thrust vectoring stuff and coming up with their flight computers and their gimbals and doing servos and stuff. And those motors are really cool for that. So I'm hopeful to see those actually certified, so that the average person so I want to see more stuff on Twitter, actually watching them do their thing.
Well, because we feel that, I mean, the H13 so far is the extreme of the 29 millimeter long burn motor. So we're very hopeful that applying this new design to the G8 and also to the G12, which we announced, I think, after the G8, will render them able to be certified. So hopefully, maybe by the end of the year, we'll have some good news in that area.
Exciting.
That's pretty exciting, right?
Yeah.
Even for those of us who fly finned rockets.
Well, yes.
Yeah.
Yeah, the thrust vectoring is cool and everything, but I just don't have the patience to do the flight analysis afterwards to figure out what might have gone wrong. I did a couple of like test flights on it, but never did the follow up to get the PID numbers right. So it's a long and arduous process, but for people that like it, it's amazing.
Well, I can tell you that flying the long burn motors and finned rockets, with electronics is awesome. Okay, that's
great,
and that's what I like to do. I've been a long burn motor fan since probably the 70s or 80s. So those are my favorite type of motors because you definitely get your money's worth from the duration. It's not over in 1 or 2 seconds. Continue with your question. What I found in terms of this new contest with the unlimited altitude was that you need a bigger motor, at least 38 and possibly 54 millimeters. So, it was going to be a big secret, but now that the launch has been postponed, I sort of did a full disclosure on it. I came up with a K76, which is a dual thrust motor. It's kind of like the I-59 in concept.
Mm-hmm.
You have a white lightning boost grain and a warp 9 sustain, but it's in 54 millimeter. So it burns 20 seconds. And
wow.
Yeah. You have three full seconds of boost, which would really throw the rocket up pretty high just on that. But then at least I think half the impulse is in the rest of the 17 second sustain portion.
Oh
wow! So that's the thing I like. Propellant X, man, that formula is crazy because there's 2 styles of it. The kind that burns in a fraction of a second, and then the long burn core burner, not the core burner types. Yeah, the end burners. Yeah, well, we have the catalyzed version, which is in the K1103, I think. And then the non-catalyzed is in the 05280. There's really not that much difference between the two. But when you get a long motor like that, you don't want it. You don't want it really burning that fast. It's already right.
So, yeah. But the problem with X is it's extremely erosive on nozzles, and it's hard on the hardware, and it's hard on the liner, and it's just to tame that thing it took us 5 years, literally on the O motor to try to tame it. So
I believe it. I've seen that stuff burn, and it's crazy.
Yeah. So
now let's move on to one of my favorite ones. I like the heavy boost, get it off the pad, like throw 100 pounds in the air quick and fast. Is there any new developments on that Super Thunder that you guys came out with about a year ago, I think, or 2 years ago?
Well, we were going to make an end motor with it, and we still may. That just hasn't been a high priority.
Sure.
But we found that it was, going back again to the long burn motors, we found, not only is it good for a core burner, but typically these fast burn propellants are also good for end burners. So Super Thunder found its way into the H13 and the G12 and this K76 I was talking about, and some other things that we're working on. So it has a dual function. And I would say as far as core burners go, the only other plan we have at the moment would be this end motor. It's probably over 10,000 newtons average, but we haven't fired one yet. We got a design, but not. Yeah, I think people are kind of afraid of those high thrust motors. We don't sell a lot of them,
right?
Because they're you have to build pretty robust to handle them.
Yeah,
That's
Jim does
beast.
that.
Yeah, I fired one end motor in my lifetime, and that was with a couple of high school kids that built the rocket and went through the process. So we took it out to California to fly it, and man, it shredded in the air. This carbon fiber fiberglass rocket just shredded on this end motor. So it was interesting to see. The kids were not that disappointed because they had some awesome videos. So good for them.
Yeah, the shreds can be just as fun to the observers, but not necessarily to the owner.
Yeah. Well, see, a motor like that, you have to design a rocket around it, I think. So and you have to make sure that thing's going to be able to handle that thrust of a motor like that.
Well, see, that's another advantage of the long burns is that you can build, less robust rockets. That was the whole idea behind the I-65 way back in the 80s, and those other long burn motors was people could put them in basically rockets with model rocket construction techniques, right?
Mhm.
Right. And they would be able to handle it.
Yeah. You can fly high power with more easily built rockets.
Lower G forces on the rocket at takeoff.
Right.
300 miles an hour up to 15,000 feet, right?
There you go.
Yeah.
Nice. So what we're going to do is we're going to take a quick break, and we'll come back with more with Gary Rosenfield from Aerotech, and that'll happen right after this. You're listening to The Rocketry Show.
Hey, all you rocket geeks out there. Do you like doing in-flight videos of your flights? And do you ever use those keychain cams and unfortunately sometimes only get videos of your thumb? Hey, this is Gene from The Rocketry Show, and that used to happen to me. I used to use those old keychain cams only to get nothing very good quality. But I found a solution to that, and it's Insane Rockets. It's an app that's available on the Google Play Store for Nexus 5X and higher. Now get this, it does 4K video. But not only that, it'll upload it automatically to the cloud and provide you real-time telemetry while tracking your rocket through Google Earth. It is amazing. Available on the Google Play Store, Insane Rockets app. It's crazy. No, wait. It's insane.
It's time for Serious Rocketry. Serious Rocketry, since 1998, providing the Rocketeer with great kits, motors, supplies, and more. They have lots of products in their ever-growing web store with fast shipping, wide selection, and courteous service. You can also check out the amazing and popular Serious Rocketry kits that harken back to the days of fun-to-build detailed kits that are more than just 3 fins and a nose cone. And today, I would like to shine my attention and yours as well onto some neat products here that Serious Rocketry offers. And they offer for the high-power Rocketeer the full line of top flight recovery parachutes. And the ones I like to focus in on are the ones I like to use for my rockets because they tend to be kind of smaller diameter rockets, Nesru Aries and Comanche, which are like BT-70, BT-80, but they have the weight of a much larger level 1 rocket because of all the stuff going on in there. So there's not a lot of space to pack a big enough chute. And in my case, I'm using 60-inch chute for these rockets to bring them down. And I found that the only way to pull that off is with the thin-milled ripstop nylon chutes from Top Flight Recovery. And Serious Rocketry has them. You can get the sizes from 9-inch to 120 inches as you need. They're made out of ripstop nylon, thin-milled. It's amazing how much parachute you can pack in a small space. So if you're looking for something like that, or you're looking to save weight and how much space you've got in there, look into the Top Flight Recovery parachutes from Serious Rocketry. And also, if you want to get around using dog barf and wadding and all that, you can also buy from Serious Rocketry the Nomax Firewall chute protectors. They have sizes from 3 inches to 36 inches, all at Serious Rocketry. And while you're there, Serious Rocketry's website features real-time stock tracking, which lets you order with confidence from their online store, no having to call or write to see if something is really in stock. When you're ready to fly, Serious Rocketry has motors and hardware in stock from Pistis through Aerotech High Power, as well as popular electronics from Jolly Logic, as well as Estes. Be sure to check them out and ask them about their club specials while you're at it. Visit their websites today at siriusrocketry.biz and .com. Serious Rocketry, for the serious Rocketeer. Lock Precision Rocketry manufactures a full line of high-quality precision fit components to meet your building, repairing, and customizing needs. Lock Precision believes in making rocket kits as light as possible while maintaining the strength required to fly with commercially available motors. Lock Precision offers a wide range of rocket kits from the 1-inch diameter Lock 1 series to high-power rockets reaching 7.6 inches in diameter. When you visit lockprecision.com, be sure to check out their Performance Series kits, featuring such designs as the Black Brand 10, the Caliper ISP, and the 3.1-inch diameter Iris rocket. All of Lock Precision's performance kits comes with everything you need, including pre-slotted airframes, high-grade precision-cut plywood fins and components, as well as ripstop nylon parachutes, rugged shock cords, polypropylene nose cone, and instructions. The name Lock Precision has been synonymous with mid and high-power rocketry for over 30 years. Check out lockprecision.com to find out why. Lockprecision.com. Fly higher. Fly Lock.
The Rocketry Show would like to thank the following patrons for their support: JohnRocket.com, Joe S., Paul Olivieri, Sam Feinberg, Michael Airward, Brian Schickenberger, E. Hundell, John Thompson, Mark McBride, Doug Wade, C. McCauley, Carl Hunting, the Piedmont Student Launch Team, Steve S., Timothy Hoagland, David Simmons, SBR Fusion Rocket.biz, John Kushner, Christopher Short, Kelsey Black, and Brian Renneker. If you wish to show your support and become a patron of The Rocketry Show, just visit us at patreon.com/TheRocketryShow.
Welcome back to The Rocketry Show, TheRocketryShow.com. We've got Gary Rosenfield in with us here, and we're talking Aerotech rocketry stuff. And I know the gang has some questions they want to jump off with here. So turn it over to you guys. Jesse.
Hey, Gary. Thanks for joining us. I've had the pleasure of meeting you a couple of times, so that's always fun. It's good to see you around, and whenever get to hang out with you guys, and met Dan a few times too. One of the questions that I actually had for you was concerning your response that you got on your Aerotech Mega Initiator. It seems like a lot of mid-power flyers love the 2.6-inch diameter kits, and you have a ton of them, Mustang, Aero, and of course, everybody always has an Initiator. What's your response been like on that 4-inch diameter big guy?
It's been a pretty good response. The kit is expensive because of the cost of the materials and the parts, but I think we're going to explore other upscales like maybe the Aero or the Mustang next.
I was hoping you would say that. I was hoping that you'd say that you'd explore bigger ones,
Mustang's cool.
Oh, yeah, it is.
And, it's the response has been good enough that we would like to do some more. But, especially in this particular time in the economy and the situation with the pandemic, kits are very capital intensive for us.
Right.
So we've been concentrating on motors, which are a little less because a lot of times, we're using things that we already have, just putting them together in different combinations. So coming out with a new motor is not that costly, generally speaking, for us. So we get a lot of mileage out of that. So, we're just trying to manage the budgets.
Oh, yeah.
Not get ourselves too far extended. But, when things start opening up again, we would like to, we're definitely exploring more kits and looking at bringing back, and not to delve back into the model rocket side too much, but there's a number of discontinued Quest kits that we found parts for or designs for that we'd like to bring back. And I would like to bring out some more upscales and potentially some other ideas. We haven't been throwing around a lot of ideas on kits lately. So we're just trying to make the most effective use of our resources right now.
Sure. No, it sounds good. We'll definitely be keeping our eyes open.
Yeah.
I do have a lot of flyers that I know personally that do love that Mega Initiator. I got to see the one that Tim Van Milligan built because it looks like Apogee is going to be carrying those. And I was excited to see that he had built that and put it in the showroom. And I think he's going to try to launch it on one of our local launches. And it'll be the first time that I see one actually go off. I do have one myself. I hope to get that built for you guys too and give you some feedback on it also. So thanks a lot for thanks a lot for going through and making those because even having, the upscales from other Quest kits, as soon as you said that, like 4 or 5 different rockets from the Quest line that could be potentially upscaled came into my eyes. And, we kind of always would like to see like what a 4-inch diameter Icarus would be like. But I know that's older and may not be in the current library, but, I'm just rambling. I'm just rambling now. So that's where I go.
Give us your wish list and we'll look at them. I think for us to really get into the kit business more, we're going to need a full-time, or close to full-time designer to deal with that. So, and that's potentially in the cards down the road.
The Initiator kit has a great pedigree to it. It's got a long history that goes back a little bit because it is kind of it's buzzing around the field a little bit when people are talking about the 4-inch. So could you mention a little bit about that kit?
Well, okay. If you want to go back all the way, that was a Bob Sanford design. And he did that when we were working on the Aerotech project. Do you remember that?
Yes.
Okay. So late 80s, I got together with Lee Peaster and Paul Hans and a whole bunch of other people. And and we hired some employees, including Bob Sanford, and we came up with a bunch of kits, and the Initiator was the like the flagship kit. And unfortunately, that we went to the St. Louis HIA show. I think it was in '87 or '88. I think it was '87, and we ended up getting $600,000 in opening orders. And for back then, that was
wow.
It's still a lot of money, but it was a lot of money back then.
Sure.
We essentially had raised enough financing to do the R&D and finance the trade show expenses and go there. And we had other people lined up to help finance production. But unfortunately, after the show, even with the success that we achieved, for whatever reason, potential investors backed out. So we were kind of left with that. And there was just really no way for the company to move forward. And then basically, eventually we ended up liquidating Aerotech, and Paul paid for all the outstanding bills that were due. And then he rolled that into an investment into Aerotech. And, one of the things, part of it was the Initiator design, as well as the launch pad, the Manus.
Yep.
And that was about it.
Right.
I mean, I don't think much else got into Aerotech other than the pad and the Initiator, because the pad, we had invested a lot of money on the mold.
Oh, I believe it. I have one.
Mm-hmm.
Yeah.
That mold was probably 80% complete at that time. So we had to pay and get it finished. And then the Initiator originally was going to have plywood fins, plywood rings, and more or less kind of a conventional construction. And when we went to try to source those fins, for whatever reason at the time, we could not get reasonably priced plywood fins. So, yeah.
Just because the angle of the cut on those fins, I guess.
Yeah,
right?
who would ever
I
thought
don't know
that?
what it was. I mean, I don't think they were doing laser cutting then. And
Yeah, sure.
Right.
so that's when we ended up deciding to go with the molded fins. And, there was so many advantages to that with the, built-in airfoils and fillets and that kind of thing. And then being able to put the tabs on there. And that's kind of where the fin lock ring came from too. We just looked at what we had, and we improved it, and with what we anticipated to be our new manufacturing methods and so on. So that's kind of where the Initiator came from. It was basically resurrected from Aerotech. I don't think we've done any other. I mean, we technically own the designs, but we haven't done anything, I don't believe, with the other kits. We could, in the future at some point. But at this point, what is it? 33 years old. So.
Yeah, but it's still a cool design. Those like you see those fins, what's going to fly. It's going to fly well. Provided the builder built it
very
well.
recognizable. I was mostly talking about the other kits, like the Emanon, which is no name backwards.
Oh, wow. Okay. See, now I get it.
Yeah.
So, I've got another question moving back into motors. You're talking about, going through the process of, coming up with a new motor. How does that work? Could you basically give, a layman's, description of how that process starts, just out of curiosity?
Well, I mean, at this point in time, I do the motor design. Okay. And, unless it's a real special motor, we'll use one of the propellants we already have developed. And then I will put into a ballistics program the parameters, of the motor, and iterate it back and forth a few times, and see what comes out of it. And then I'll come up with a preliminary drawing of the motor, and then I hand that to Carl Baumann. And Carl is our head of R&D and facilities. He's a vice president of the company, and Carl is very, very good at turning what I put on a drawing into a finished product.
You need somebody like that.
Yeah, I know. He's just like, give them a drawing, and then a few days later, here's a motor to test. So
Cool.
very, very helpful. And then Carl will typically come up with all the delay parameters, and if you just tell him what you basically want, and he'll work out the delay lengths. I get involved from the first test. Both of us kind of work together on it. So we'll be doing the static test, and I'll be looking at the thrust curve and back calculating the pressure out of it, and seeing if we need to adjust the throat diameter, if not, or any other parameter we've got.
Now, when you do that kind of thing, like just adjusting the throat diameter and the other aspects of the nozzle, do you go back and then have to fabricate a nozzle just like it is in the kit, and then you go back and test again, or do you have a shortcut way of doing that? I'm just curious.
I mean, we have many different nozzles we can choose from, so we'll just take one that's close and roll the throat out to what we think is going to be the proper throat diameter. And we're adding to that as well, because we just added a new 75 millimeter nozzle, which is we just call it the 75 millimeter small throat. It's for the motors like the 1, 2, and maybe some of the 3 grain motors that we're using, the Medusa nozzle, the multi.
Yes. And I was going to ask about that too, but go ahead.
Okay. Well, that nozzle came about because of the cross loads that were, the 75 millimeter Aerotech reloads that we're putting into CTI casings.
Mm-hmm.
But the CTI motor is designed in such a way that the nozzle is kind of buried down inside there. There's that retaining ring that holds it in, so it's further down inside. And if you use a Medusa nozzle, there's a good chance that some of those outer throats are going to generate plumes that will impinge on that part of the motor and melt it. So we didn't. Figured we couldn't really turn those into crossloads without a solution to that. And Carl's solution was, let's just drill the center throat out really big and leave the outer ones undrilled. But in a lot of cases, you just drilled out a straight hole, right? There was no expansion. It looked pretty bad and dropped the performance a little bit. So I ended up designing a new nozzle that kind of could handle those smaller motors that can't use the larger nozzle that we have that has I think a 0.685 throat. So that's reserved for the 4 and larger grain motors. So yeah, I mean and we ended up having to test a few for Tripoli, and they gave it their blessing, and now we're replacing the Medusa nozzles with that nozzle. So we're going to continue selling the Medusa nozzle on the RCS parts store for people that want to use it, because it is a pretty easy way of making, taking one nozzle blank and turning it into something you can use into, from 1 to 6 or more grains of propellant.
Right. So that original design was pretty much to be for flexibility then.
That is correct. Yeah. Because, way back in the day, we didn't have the funds to make, several different nozzle blanks.
Sure.
Doing that was a way of conserving funds.
Oh, that's cool. I didn't know. I've always liked to see the flame coming out of a Medusa nozzle. It's like a couple of flyers that I know have used those, and it's always cool watching one of those launch.
Oh yeah, it's a great nozzle. I mean, we've really never had a problem with it. The only issue that ever came about that I can recall was on the 54 millimeter when we brought out the K1275 red line motor, that long one.
Yeah.
And, I think it required all the throats to be open. And the problem with red line is it's extremely erosive on phenolic. So it was the only time we ever had this happen. We had, I think in static testing it didn't do it, but when we flew a couple of them, we had 1 or 2 of them actually burn through the webs between the nozzle throats.
True.
So it was clear that, that it had limitations. So that's when we end up designing the large single throat nozzle for the 54 millimeter reloads.
Wow, that
makes so much sense now.
Yeah, I'm just starting to dip my toe into research a little bit here and there and trying to pick the brains of Chris Pearson and some other guys around my area about all that. So you'll be happy to know, Gary, I'm going to be buying my first secondhand mixer soon. So
Oh, great. Great.
looking forward to hitting up on the RCS store to get some parts to build these things.
Yeah, no, that'll be great. Speaking of that, I'm seriously considering putting up a motor design library on that site. And
that'd be cool.
Actually putting up what I would consider non-proprietary drawings of the DMS motors up there.
Sure. Wow, that would be cool.
We could put the reloads too, but those are already on the Aerotech site.
Right.
So people could literally duplicate or, use those designs because, we are selling propellant grains for those that don't want to mix their own.
Right. I did notice that. And that's actually a good way of if somebody's interested in starting to do the process and they don't want to mix yet, but they do want to change the characteristics of a propellant, they can go and get nozzles and then they can get the pre-made grains. And it's a pretty economical way to do it.
Yeah. And you get to do research without, in a more straightforward way without, getting too much into mixing and the chemicals and all that stuff. Because I think some people, they feel it might be a little too, I don't want to use the wrong word here, edgy, depending on what kind of, if they're living in an apartment. Or something.
Right.
Yes. Just, it'd be more like putting a reload motor together rather than, strictly making propellant.
There you go.
From my experience, the most dangerous thing was the acetone to clean up with, at least from my perspective, the way I'm learning it.
Yeah, that's probably true.
So I have a mundane question, but it's one that there's variations of this that I see come up from time to time. So I will use my story as a way to jump into this and a couple other things. So I've put together about 2 years ago an I-200 motor and a casing. And it got to the time where it wasn't enough time to fly it. So I just, loosen up I didn't put the black powder in. So I just loosened up the ends of the motor. So to take the pressure off the O-rings and it's been sitting in my motor case for 2 years now. So I was like, I need to launch something with that. But after sitting out like that for 2 years, what would your recommendation be for me to make sure that's ready to go when I do fly it? Or what should I look out for on that?
Well, with the modern reloads that have the RMS Plus delay, which is just when we switched to the delays that were in the plastic tube and the O-ring was around it.
Mm-hmm.
A lot of people probably don't remember this or weren't in the hobby at the time, but when we first brought out reloadable motors, the O-ring seal for the delay was at the face. In other words, it was on the propellant itself, on the delay propellant.
Mm-hmm.
And there was concern that over time, not the O-ring itself, but the delay propellant itself could take a compression set from that O-ring, and eventually lose the seal, effective seal, right?
Mm-hmm.
So, and I think we observed a few failures along those lines, but like a lot of other things in hobby rocketry, you can't do a super effective failure analysis because afterwards everything gets burned up and there's very little evidence.
Yeah.
Right.
So, but we suspected that could be a problem. But after the new delay design came out where the O-rings are on the outside of the delay and it's on a plastic tube, you really don't have that issue anymore. So I think a lot of that tribal knowledge or whatever just kind of got transferred down the line, and people keep backing off their closures. I think with a modern reload, you don't have to do that.
Okay.
Yeah.
That's good to know.
Yeah. Okay.
If you're still using now on the model rocket reloads, they still use a delay face seal, right? The O-ring is on the end of the delay. So I think that advice probably is valid. It doesn't hurt to, not to tighten them all the way down, but on the high power reloads, just fly them.
Okay. Cool. And basically, as a follow-up to that, what are the most common mistakes you see people make with their motor reloads?
Well, there's a bunch of them, but I always recommend read the instructions. Make yourself a little checklist if you have to. One of the common failures is on the 29 high power, people will reverse the two O-rings. They'll put the fat O-ring at the nozzle end. They'll put the thin O-ring at the bulkhead end. That's a common failure. Another one is sometimes people will reverse the position of the delay and the delay spacer. So if the delay spacer is up toward the black powder side, the motor will fail almost instantaneously. You've got to burn through right at the front. Those are the two main ones. Make sure that on the motors that have phenolic liners, check the liner to make sure there isn't a crack in it. And that's important because, when you put in the forward seal disc, you want to make sure that O-ring is sealing and not allowing gases to go around the outside of the liner from the front end.
Right.
From the head end, the bulkhead end, forward bulkhead. If there's a crack there, you're going to get gas leaking around the outside of the liner up at the front end. That typically can cause either a blister or a hot spot. In a severe case, it'll cause a burn through. Typically, if the motors are built according to the instructions, the failure rate is extremely low. So, just those are, don't reverse the O-rings, don't reverse the delay components. That'll solve, probably 99% of the problems.
I think I've had, I've got a little story on my L1 where I was at a 38 mil H motor, and I was on my test, and an old wizened Rocketeer was watching me build the motor, and I was following the instructions, and I was like, okay, this O-ring goes here, the seal disc, and then this O-ring goes here. No, you sure you got that right? So this guy who's like going to sign off on my paperwork is questioning me building this motor. I'm looking at the instructions, but I diverted to him. So I built it the way he told me to build it, and I KO'd. So, but I was able to turn it around the next day, and I've always joked with him about it. But, because I showed him the instructions, and he just looked at me and said, oh, yeah, you're right. So that day, though, I was able to turn around and build it. And I said, see, I'm doing it this way, according to the instructions. I had them right in front of me. So note to yourself, always follow the instructions, not necessarily the old wizened Rocketeer who's flown a lot, because the instructions are what you got in your hand,
Exactly.
Yeah, it's going to be hard to have that memorized. So your heart had to have dropped that day. I can kind of feel how your emotion would be, but I'm glad you came back from that.
Well, it did, but see, here's the thing. The rocket was fine because I built heavy, as we all know, and I just shaved off maybe an inch or so from the airframe on the booster side of it, and I happened to have another reload with me just in case, and another casing. So I turned it around that day, shaved off the rocket, built the motor the right way, and flew it within about an hour and a half and got it. So I was determined that day.
Turn lemons into lemonade.
Yes.
Yeah, and then every time after that, I gave this one Rocketeer guy a lot of stink for it, and he always accepted it because he knew I was right. So,
well, another piece of advice I can give is if you have the opportunity, build the motors at home. Build them before the launch if you can.
Absolutely.
And because there's nothing worse than being out in the heat and the wind or whatever, and parts are blowing all over the place.
Mm-hmm. Yep.
If you're going to face that, I'd recommend using single use.
There you go.
Got it.
Well, single use, it's funny because in the old days, single use was what you guys were doing. And then the reloads came out and changed everything. And then going back into the single use, it's been a boon for my kids in my high school because they can all get level 1s on single-use motors, and they don't have to worry about loading it up, which is phenomenal for me because it's a great success rate for my kids getting their level 1s because of those single-use motors. So it's interesting to see how that circled back and became sort of a thing. Now, I still like building the motors because that's part of the stuff that I do, and you're right about building at home, especially for the bigger motors. But
I agree
with
you 100%.
I have a mix of both. And for my kids, I always have single-use H motors for them. So all they need to do is focus on the rocket and focus on what they're doing and making sure that rocket's going to hold up under a high-power motor. But for myself, I like the process of building it and going through, and especially one of the big motors like the M4500, my favorite motor that you guys make.
Yeah.
So
Well,
I mean, there's a
think
process
reloads
to it.
will always be more popular, and they continue to be by far the most popular type of motor. But we found that there is a market for motors that are already built, and we're trying to serve that market. So I think we've kind of reached a happy equilibrium between the reloadables and the single use, and we're happy to be involved in both.
That's really cool. Can you say what rough percentages between the two, or is it a meaningless number?
In terms of high power, maybe like 80-20.
Wow.
Maybe something like that. 80% reloads.
Okay. That makes sense.
Yeah. I'm not saying that won't change, but that's kind of where it is.
Hey, Gary, I had a question. Hopefully you can kind of speak to. Can you kind of explain what the whole aerospike nozzle production thing was about? Because I'm still kind of new to that whole end of it. And I was just thinking about that the other day, and it's kind of funny that when CG's like, hey, we're going to talk to Gary, this is something I wanted to bring up. Can you talk about that?
Yeah. This is going back a long time now, probably around 2006 or 7. And I can't remember who brought it up first, but a fellow by the name of Luke Colby, who runs a company called Triton Space now, but he was like a chief engineer or lead engineer on the Spaceship 1 or Spaceship 2's hybrid rocket motor. Somehow we got together and decided we're gonna make an aerospike nozzle for reloads. So he designed it, and we came up with an agreement. And I don't think we ever felt like we were going to end up replacing nozzles with aerospike nozzles, the regular nozzle. Mm-hmm. Right. But there was a great degree of interest in it, from a geeky standpoint and just the coolness standpoint, right? So ultimately, I think we talked about selling them on the RCS store, and but what ended up happening was the individual financed the molds, was also supposed to finance the first production run, and he never did. So we ended up buying him out, and then we did an Indiegogo on it. So I don't really have any breaking news on this, but we got enough funding that we were able to go ahead and buy the first production run.
Oh, wow.
But we're having problems. I don't know what in the world's happening with the vendor. We can't get a hold of him, and he's the same vendor that supplies us all our molded casings. So, yeah, I mean, we should have received the production run over a month ago, and I'm getting a little nervous on it. So, we're going to hang in there and try to tell the people that supported it that we're still waiting on receiving them, and we'll certainly ship them out. But if anybody wants their money back, we'll be happy to give them their money back if they don't want to wait on receiving those. So it's I don't know whether it's a COVID related thing or what, but it's these nozzles, they're not as robust as a regular nozzle. They're more susceptible to erosion and heating. So that's why when we announced them, we recommended that they be used for short burn motors and cool burning propellant, like a Black Max type of propellant, or maybe a Warp 9 for a half a second or a second or something like that. But they do the heating does affect them quite a bit. So, but it is a cool looking nozzle, and I'm really looking forward to getting them run and getting them shipped out. So I apologize to all those that are listening to this that are waiting. But if you want you want a refund on it, just contact us. We'll be happy to. But we are still pursuing to try to get those shipped to us. I'm pretty sure they will get here, but I just don't know what's causing the delay.
Gotcha. That puts you in an awkward position, huh?
It does, because I think it's probably the only item right now that we're having problems getting. From time to time, but that's not nearly the same problem. This is a single vendor that's providing these, and
Well, not to put you on the spot. I mean, that wasn't the reason for the question.
Yeah.
Just, I was always looking at that as like, how does that work? How is that different? And then I started reading about it, and taking the opportunity to have you on the show, I just wanted to get your input on it. But no, thanks for being transparent with all of us. But at the same time, thanks for the history too, because always learning where the new things come from, I think, is the basis behind some of our questions. So thank you, Gary.
Yeah.
I don't think you're going to see, Aerospike nozzles getting out into the product line.
Right. Okay.
It is a specialty item. I think, the best place for it is probably on the RCS parts store. We could conceivably come out with a reload with that nozzle, if it all works well, but definitely not replacing all the other nozzles.
Yeah, you got something that works. Why change it? But it's nice to have that option for the research people out there.
It is.
I'm going to go ahead and ask, since you're still on with us, I'm going to go ahead and ask, are you going to be able to go to Airfest this year? Because I understand the registration is still open, and it is still going to happen.
We are registered, and unless something out of the ordinary happens, we are planning to be there. So, all
right. So those of you that are going to Airfest this year, make sure you stop by and say hi to Gary. I'm sure he'll have Dane with him and probably a couple others.
Dane and Carl will be there. So
okay, great. Oh, wow. I wish I was going this year then. It'd be nice to hang out with you again.
Yeah, that'd be great. We're looking forward to it. Big time.
And I'm looking forward to any launch right now.
Yeah.
Yeah, I hear you. One thing I've been working on some stuff for this Hamster Dance contest, even though it's been postponed for a year.
Yeah.
But I finished the rocket that I was going to fly. And
Gary, take a moment for folks who don't know. Tell us about Hamster Dance.
Hamster Dance is Tom Blazanin, Deb Collins, and Dave Rose came up with this contest. And it's kind of a long story. You can go to the page and read about it. But basically, they came up with a contest that if the NAR was to do research, what kind of a contest would they do? So this was originally going to be something with a 3-pound limit. And but once they figured out that this was going to be a high power activity that required FAA waiver and all that, they just figured to raise the limit to 5 pounds. And so it's a 5-pound weight limit, all non-metallic, single use. And initially they had a 15,000 foot ceiling, which for the first 9 contests. So it was about, who could get closest to 15,000 feet. And a couple times, a couple guys, including myself, got to over 13,000 feet. But then last year, Tom decided to change that and eliminate the ceiling. So now we've got an unlimited altitude, which changed the whole focus of the contest.
Right.
And the whole nature of it changed. So as it turns out, you can go a lot higher than 15,000 feet with a 5-pound rocket.
Yeah.
Yeah. So there's been a lot of discussion about that. We've got 74 people on this group now. And the discussion's been pretty interesting.
Now, when you say research motors, is that limited to research motors being motors that are made by the Rocketeer themselves?
That's correct.
Triple E kind of stuff.
Triple E, yeah, fully sanctioned, safe stuff, which I'm kind of learning to do through Triple E. And but anyway, so that means that the rockets are limited to research motors only.
That's correct. Yep.
Okay.
The flyer has to build his own motor. Now, it doesn't mean he has to mix his own propellant, but he has to, assemble the motor themselves.
Okay, so it could be commercial motors that.
No, it can't be commercial. I think you could probably take a reload and load it into a single-use casing, and that would probably qualify.
So so it has to be a single-use motor then. That's the rub.
And non-metallic, no metal parts other than swivels and quick links and that kind of thing. So,
okay, that's an interesting challenge.
It's a lot harder than people think. Last year, we had 17 entries and only 2 qualified flights. So, yeah.
I believe it.
It's challenging for a lot of people. I think, as I made a mention of this on the group today, I think that there's a lot of good motor makers out there in AAA research, but the single use and non-metallic part throws people off. So it's a lot than metal case, right?
So, I mean, then, obviously the DMS motor casings that's kind of a phenolic carbon material or something.
They're filament wound fiberglass.
Yeah. Okay. So,
Yeah.
I mean, that would probably be the first go-to to think about, I imagine, but then putting it all together, that could be interesting. And then keeping your pressure to the point where it's not going to blow the casing is always fun too, I bet.
Exactly. And I think the part of the problem is some people they don't do enough testing. They might test one or even go up with a motor that hasn't been tested. So you get a lot of Katos.
Which could be awesome.
Yeah. Well, it's kind of a fun event. I mean, it's kind of captured my imagination because it lets me explore, new motor design and getting back into actually building a rocket, which for quite a few years I was sort of out of it. So Hamster Dance actually got me back into flying, 8 or 9 years ago.
Well, we have taken up a huge chunk of time with an interview with Gary Rosenfield, but it was a great chunk of time. We learned a lot and got a lot of great information, and hopefully all the Rocketeers out there enjoyed it as well. And thank you so much for coming on with us, Gary.
Yes, thank you for spending some time with us, man.
Great talking to y'all, and hope to see you at a launch sometime when we get over this lockdown situation.
We're all looking forward to 2021, and we'll be seeing you a few times, I'm sure, Gary.
That will be great. Think positive thoughts and be a much better year next year.
Yes.
That's right.
Indeed.
Thanks again.
All right. You're welcome. Thank you.
North Coast Rocketry, one of the first high-power rocketry kit companies ever, takes advantage of over 30 years of high-power experience by a world-class Rocketeer. You can look to North Coast Rocketry to expand your high-power rocket fleet. In addition to great kits, North Coast Rocketry also stocks lots of must-have items and accessories for every Rocketeer's workshop. Find out more about these kits and other great products today. Go to NorthCoastRocketry.com. And while you're there, don't forget to get their latest catalog, NorthCoastRocketry.com. Advanced rockets that are easy to build, fun to fly, and look great on display. It's time for eRockets. eRockets is your home for unique model rocket kits, as well as the world's largest selection of rocket parts from Semrock. They've been in business since 2009, and they don't just stock many of your favorite in-production kits. They also produce their own versions of popular out-of-production models that many of you have come to enjoy over the years. Jesse, you've been looking at some stuff that is sort of Aerotech themed in a way, or high-power rocket themed. What'd you find?
Indeed. So one of the shops that we have here locally used to sell a lot of Aerotech products, and they still do. And one of the first rockets that I noticed when I went to that shop particularly was the Aerotech Mirage. And this is an eye catcher. And this rocket is a long 87-inch rocket at 2.6-inch diameter. So it's, it's not too shabby. It's a pretty big rocket, just looking at the length of it, the 3-fin monster. This thing is huge, but it's still light enough to fly on F and G sized motors. So you could put an H in it if you want to, but just being able to fly this at your local field on an F or G motor is, that's a pretty big deal for a lot of us flyers, especially like in my club where, you don't have a high power waiver. So, good kit for that. Another thing that is interesting about this particular rocket, if you haven't built a rocket with a baffle yet, this is a good kit to learn on because it actually does have the internal baffle. And, that's, that we don't have to use wadding, et cetera, et cetera. The Aerotech kits, they all come with the parts that you need to build to complete your build. They include your shoes, your shock cord mounts, motor mount assemblies, pre-slotted airframes. These have molded fins, they have instructions and decals. So it's a complete rocket. You don't have to, go and buy anything else. Another add-on that they've done, most of the rockets from Aerotech now come with the 29 millimeter aluminum retainers, and now they're starting to, include the conformal rail guides.
Nice.
So eRockets has this on sale, guys, and it's a deal. It's $99 for this huge kit. So if you wanted to, get into some higher powered rocketry, some mid power into high power, go grab an Aerotech Mirage from eRockets.biz.
Cool. And if you need parts for your own custom builds, what I like to do with my level 1 rockets is I like to use the BTH, the heavy walled BTH 70 and 80 airframe tubes. They're great for level 1 rockets, and I never had a problem. I even had that the airframe tubing for the most part, survive a Kato. So it's good stuff. It's better than trying to use the thin BT-80 stuff that's typically used for model rockets. And you can find that from the eRockets.com Semrock line of airframes, nose cones, centering rings, motor mounts, and so much more. eRockets has more rocket parts available than anyone else on Earth. Check out eRockets.biz today to learn more. eRockets.biz. If rocketry scares you, buy a train set.
The Rocketry Show would like to thank the following patrons for their support: Les Rabrin, Steven Spencer, Bill Cook, Jason Cook, Gary Rosenfield, Greg Ziegler, Toby Vanderbeek, Ken Blade, Eric Hamilton, John Beans, Scott Holla, Guy Wadsworth, Phil P., Tom Rum, Jeff Codes, Stephen Ray, Amanda Ho, Steve Sainer, and RailButtons.com. If you wish to show your support and become a patron of The Rocketry Show, just visit us at patreon.com/TheRocketryShow.
Alrighty, and that was a very fun interview with Gary Rosenfield of Aerotech.
I really enjoyed the conversation with him. Yeah, so thank you, Gary, once again.
Ever since the show started, I've always wanted to interview Gary, and it just took a while to get to know Gary and for Gary to get to know me and us. Mm-hmm. But now I'm glad that we know each other because we're able to talk and have great shows like that. So I'm looking forward to more conversations with Gary. That was enjoyable.
And I really meant it, guys. If you go out to Airfest this year, he's hoping to be there. If you get a chance to go meet Gary and Dane, please say hi. Please introduce yourselves. Mm-hmm. He loves to meet his clientele and everything. But you know what, CG, I was going to ask you, like, after the interview, did you go and start looking at all the Aerotech products and all the different motors, just to start looking at all the different thrust curves? It's like, ooh, look at this. And then you just kind of re-educate yourself. Did you have that happening? Because I totally had that happening.
Well, there's the early stages of it. And the funny thing is I started doing some of that before we started recording the show, only because I've been wanting to get into long burn motors, and I never really thought about long burn high power motors. I mean, I in my club, I was like the king of the E9 motors. And when I got back into rocketry, that's just pretty much all I flew for a while on the rockets were the E9s. And I had these rockets dialed in, and it was fun. And then I started getting into the composites, and, of course, the composites have the shorter burn time, but they, have more punch, and I can lift heavier things. So I kind of drifted away from all that. And I was just flying your typical, H-128s, H-180s, and I-200s, and, whatever other White Lightning, because I love White Lightning builds. But what got me...
I do too. I do like those.
Yes. Just because of the aesthetics. I mean, there's no... people go, I would better perform. No, I just like the way it looks. It looks like a NASA rocket. So anyway, or a military, thing. But the thing that piqued my interest was at the NARAM at Geneseo when we did the show there. And they had the I-59 contest where all these people had these rockets that flew on I-59s, and the challenge was to get the closest to a mile. And so I'm thinking, this sounds cool. And I was like, we were doing the show, I was setting up equipment, I think we were getting ready for an interview, and the first rocket launches, and I knew it was a composite motor, and it just kept burning and burning, and I turned on, what motor is that? And I had to go, what motor is that? And it must look like a psycho or something. I had to find out, I-59. I got to give me one of them.
I-59.
It was a nice long burn,
In talking to all my buddies from the Midwest here, I got Ryan Toso. He flew at, I think it was one of the Midwest Powers. He flew a M750, and I think that's got a 13-second burn. And it's a White Lightning. Gosh, could you imagine that? And he flew it, of course, in a 7.6-inch Goblin, Team Goblin. So, long burn motors. Well, I got to do an M750 on something at some point, man. So
yeah, that I-59 sparked my long burn desires, and ever since then I was flying my the usual ones I fly, and they're flying great and it looks wonderful, but it's like, it's not long burn though. I need the long burn. And the problem is all of the rockets I have right now, level 1, are all 29 millimeters, and the I-59 is 38. Right. So with that in mind, like one of the projects I started doing is I started simming up a rocket to fly an I-59 with 38.
Okay.
So, so I'm getting into that, and I'm looking ahead at level 2, and there's some nice long burns there too. So, and then I learned, and then this episode I learned about the H-13 that Gary was talking about. And it's like, oh man, yeah.
Just getting excited.
Exactly.
Got to go and look at that catalog. So,
yeah. And then he's got the G8s coming out, so that's going to be fun too.
All you vendors, ramp up on that Aerotech stuff. Get it in our hands, please.
So to answer your question, I was sort of ramping off into that kick to see, for fun motors, because a lot of the stuff I'm doing with the rockets are kind of like coming to like my experiments are coming to a close as far as level 1 goes. So the level 1 is transitioning from that into just having fun. So
there you go.
And I'll still be flying. That's what
it's all about, man.
Yeah, I'll still be flying my test things on it, but it's not like I'm doing hardcore experiments now. And a lot of that stuff is going to shift into level 2. So there'll be some experiments with my level 1, rockets. As I go 38 millimeter, I can start experimenting with rocket designs and getting a feel for how a design would fly, so that when I upscale it to level 2 for the first flight, out of that I'll have a design. But the primary thing is a lot of the rockets like Ares and Nezuru and all that, they're kind of becoming fun rockets. So anyway, there you go.
No, it's they're famous rockets now, and at some point I want to hold these rockets in my hand. It's like Stanton Earwood and a little green alien dude. Like I got to hold that guy in my hand. I don't know if you've seen those pictures.
Mm-hmm.
How the little green alien dude helps him pick out his parts for the rockets and stuff.
Mm-hmm.
But I got to hold that guy in my hand. So at some point I would want to hold Nezuru and I want to hold Ares because they, they're popular. So.
Yes, Ares is pretty impressive when it's fully loaded and it's like, this thing is heavy. Yes, but wait until you watch it fly.
Has James seen him? Has he put hands on him?
Yes.
Oh my gosh. I'm so jealous. And I got to touch his Archer too. So
the only rocket he's not seen fly yet is Ares.
Okay.
Because that's only flown twice. And that was at NARA, the Geneseo. Noob, I think, missed the launch.
I was going to say, oh, no. Okay.
He was waiting to see it. Then he flew a rocket and he was out looking for it.
Oh, no.
That's why he decided to fly,
happens.
Punch up Ares. He may have seen, no, he was gone by the last day when I flew it again. Beautiful day, but Noob was gone by then. So, yeah.
I got it. So, this last launch that I went to, CG, we did some certification flights, and I didn't even launch anything, but I was so busy that day just helping other people out and everything. It was a lot of fun. So it's funny that you say that he wasn't there because he was flying his own and, he missed that one. So it happens to us all.
Right. So what else have you been working on?
Oh, man. So, I am working on my level 3, and you guys all heard me talk about the glassing, right, CG? Mm-hmm. So I've been really into fiberglassing cardboard rockets, and working on my level 3. It's a 7.5-inch cardboard rocket with a lock tubing, right?
Mm-hmm.
I tried to do the 2 pieces that are going to be the booster. It's a 5-foot piece altogether. I tried glassing that in one shot, and it doesn't look as good as I would like it to look. So trying to do some other methods to kind of make sure that I don't put a ton of weight on there, but yet make sure everything is cohesive and that it's even all the way around. So, talking to some other folks here, this is where we start talking about maybe I should have tried a sock and then done a rotisserie method. On rockets that use that booster, maybe might want to do that. And in talking to some other more experienced flyers, they recommended that maybe I should have made it, 60 inches long, that I probably should have made it like 45 inches long. And that's a manageable size, right? So maybe next time I build a rocket of this size and caliber, I might do that, but we'll figure out what's happening,
Got it.
In that process, I've been glassing the body tube, the fin can of the level 3 rocket, and I'm going to start doing the payload, and then I'm going to start laminating the fins tomorrow. I have a procedure down that I'll discuss a little bit later, but I got permission to use the oven So those of you guys, make sure you check with your significant other, unless of course you live alone, you can use your oven whenever you want to. But she's like, yeah, I don't see why you shouldn't be able to use it. I mean, just, don't cause a fire or anything. But, there's instructions out there on what you guys need to do to, put your laminated fins in the oven. And I'm going to actually, do those with a carbon fiber. And there's a method that I've been reading on that I'm going to try. And I probably should have done another rocket first, but I'm confident. I've done a lot of glassing here on a lot of different rockets, and this is going to be a first for me to do it this way. But if it doesn't work, guys, then I just don't level 3 right away. Not a big deal. And then at that point, we get new fins, and then do it again. I'm not really scared. I don't have anything to lose, except a little bit of time. So just take your time when you're doing your big projects, be patient with yourself, and, just make sure that you have a contingency. Mm-hmm. And if your contingency is just doing it later down the road, that's a good plan too. So wish me luck, guys. That's all I can say. But that's what I'm working on, CG, is just trying to get this level 3 pieced up so that I can launch it. And I'm hoping to do it fairly soon.
Nice.
How about you, man? So we looked a lot at your telemetry stuff, right? So we know a lot of your homework on that. What have you been doing as far as that realm goes? Yes,
I've been looking into that. I think on the last episode I mentioned how I discovered that the altitude was off by a few hundred feet. And I was kind of wondering what was going on there. And I think I've narrowed it down to when I was building the boards, the board that was in Mr. Bean, the rocket that launched the first telemetry test, was one of the first ones I did. And I think when I was mounting the barometric pressure sensor, I think I cooked it a little too high in the temperature, and it threw the calibration off on that. That's my guess. And
sure.
But what I did before I made that determination was I started using a different sensor in some of the tests, and I kind of jury-rigged that sensor into the existing board for another test flight with it. And I found during my test in my lab that was within, 6 to 10 feet of the other barometric pressure sensors. And that seems to be the general tolerance that you get on barometric pressure sensors because of just
got it.
the way things happen. They're all within, the better ones are within 5 or 6 feet or so of each other. And so now this is within that range. And there's a plus and minus. So there's some days they're agreeing with each other more, and then some they're a little out. But they're all within no more than 6 to 10 feet with the sensor I was testing. And what got me thinking about the temperature is I do have one of the later boards that never flew in any rocket. It's just, it's waiting to fly in Comanche later. But every time I test that board, it was in the same tolerance range as the others. So, but the other two boards, the earlier ones were kind of off, but they're off in differing amounts. So that's what got me thinking. So, I think, and I was reading the data sheets a little bit more, and I see that there's a specific temperature you have to mount them at, and I was definitely over that temperature. So, and the way I built the board, like the later one, I think it was, even though it was higher temperature, it stood a better chance of not being overheated the way I did it the last time. So, you learn more. I mean, that's what this is all about. You just learn stuff. So that's the latest there. But out of that, though, there's a little spinoff thing that I was doing, and Phil Parslow on the other side of the pond, he was challenging.
Phil?
Yeah, hey Phil, what's up, mate? He was challenging me to make a little altimeter because he just wants to play around with a little altimeter on his end, and he wants something that could be built. So I said, hey, you think you can help me with a project we can work together on with that? And I was like, okay. So he found a little OLED screen. His challenge was it must use this OLED screen for display because it's cool. And I was like, okay. So I ordered the same one. So out of that, there's a spinoff that came out of that, and that's a little baby altimeter you can fly in any rocket, and it's got a little OLED display, and it tells you, all it is you put in your rocket, launch it, get it back. You were this high. Hey!
Oh, yeah. So, what's wrong with that?
Yeah.
Sure.
And it looks kind of cool. So that I after I figured out the issues going on, I went and immediately built that one, and it works pretty cool. So next month at the mid-power, at the new mid-power field that my club has, which I can't wait, I'll be flying some of my old mid-power rockets. I've been collecting dust and launching that in those just as a big test. And I'll shoot this stuff over to Phil so he can put together one on his end. He'll be flying it and playing games with it too. So that's kind of cool. Yeah. So that's kind of a fun little project there. And
I do like hearing about your project, CG, because it is a whole different side of rocketry, and the fact that we know somebody who's doing this kind of stuff, it's development. It really is, and hats off to you for that. It's great stuff. Anybody can build a rocket. Now let's go into the science of it, and you're doing that. It's fun stuff, even a hobby level. It's great. So I love hearing about it. Thanks for sharing all this.
Oh, no problem. And the other project that's just as goofy, but it was stalled too.
Goofy.
Is a wireless interface for my computer controlled launch pad.
Come on.
And I think I may have mentioned this in a really old show.
Okay.
But I have this computer controlled launch control system where basically the whole idea is if there's anything screwy that happens at all around the launch pad and all that, it just cancels out the launch and you can't launch the rocket unless you resolve the problem or put the key out and plug it back in again.
Oh, wow.
But the idea is that the whole idea is to make it really hard to accidentally launch a rocket. So,
makes sense.
And the way it's been working is that there's a long wire that goes like a telephone wire, because I purposely designed it with just to use anything and nothing proprietary. So if the cable got damaged, I can just go to CVS and buy a 50-foot modular phone cord and plug it in and keep going. So that worked great. I mean, that thing has been in use for years, but now I'm getting tired of the wire, and
I don't blame you, man.
And I get worried about people tripping over it and all that. And I figure, I can make something wireless. So that's kind of where the data link for the rockets came from. I pulled it out of that project because I got the protocol down and I modified it for the rockets to use to send the data back and forth. And with the idea being is once I get the protocol running the way I want, then I just go back to that project and put the working code into there and finish the Launchpad project. So I'm kind of swinging the eye of CG, like the eye of Sauron, is swinging over to that project now, especially now that we have our mid-power field going. So because my rockets, especially the tube fin one, is launches specifically off of the rail on that one. So on my pad. So and all my rockets are going rail that way. So that's the other one.
Yeah.
And I have a couple of transceiver pair that can, if it's line of sight, you can get like a mile out of it. So I can put the pad a mile away from it.
Okay. Wow.
Not that I would do that, but that means that controller could be, if I need to do something custom for a high power rocket launch, it means I can just set up my controller by a pad, and then the LCO could use my controller to launch that rocket, in the future.
True.
So
yep. Or use it for club purposes too. Yeah, just whatever you need to. Wow, that's cool stuff. Once again, the other side of that board. So,
yes, and I like having like on our club launches, I just have my own pad out there, and then and the other nice thing about this is I can set it like 30 feet beyond the club mid power pads, and set it near the off but near the high power pad. And that way I can load up rockets at will, on my own.
Right.
Because I tend to be the lone wolf. I've got projects going on.
Want to take your time and
I've got my own little thing going on, and I just set up and go back, and then we can launch it.
Yeah, and then just flag when you're ready. It's
right,
like, okay,
exactly.
I'm good now.
Yeah.
So then they can go to pad left or whatever they call it at that point. Yeah. Oh yeah, I like it.
So yeah, that's kind of how I function. What else? I think those are the big things. Yeah. And I mentioned earlier that Ares and Nesru are kind of going into the fun rocket phase now, and they're not really being used for experiments anymore.
Right.
And Ares is kind of like the rocket to take over from Nesru for most of the flights, because Nesru's got a lot of sentimental stuff going on. It's getting near 10 years of flights. And so at some point I'm just, I just want to keep it around. So Ares
I'd be interested to hear, like, listeners, what rockets do you guys have that have been in service since you've started, that your original build technique, not any of your revamp stuff that you've done later? What rockets are you guys still flying? Go to the website and let us know.
Right. Yeah. You can do speak pipe on the website too. That'll be a fun,
Exactly.
fun thing. So so basically Nesru is kind of like going to become like the ambassador of the CPG aeronautics rockets, where if I'm flying in a new state for the first time, I may take, wheel out Nesru out there and just fly to get another state under its belt. And other than that, it's, rests after that. But
like I said, man, these rockets, we hear about them all the time. At some point, we're going to wind up having to clone these, with somebody. So what manufacturer wants to take up CG's kits here, guys?
And
or you can just do it. You can just do it yourself, CG.
Right. Something. So for those rockets and probably some other ones, I ordered this week a flight sketch mini altimeter, because I looked at the one Jeem had, and it's really cool. So they're
popular.
That's
good job, Russ. Good job, Russ.
So that's going to be the instrumentation for those rockets. The other designs will be heavily in use for what I'm developing, but Ares and Nesru will be flying just the off the shelf. They've got stratologgers in them for dual deploy, and I'll have a flight sketch in there for data, for telemetry,
for
and
logging.
All that.
Right.
Yeah.
Got it.
Because I love, especially on that beta software. I got to talk to Russ to get the beta too, like Gene has, because I will be happy to test that. I love the data set that comes out of the new upcoming software. It's so cool.
Oh man,
you will love it when it comes out. Trust me.
All right, I'm waiting. So no, it's good stuff. Thank you for sharing all that too.
Yeah. So that's what I'm up to. Anything else on your end?
No.
Oh, okay.
Okay. You really want to know, guys? You want to know what else is down here in my rocket lab? I have IKEA furniture down here that I'm trying to build because my wife doesn't want it anywhere in the house. So I was like, okay, well, I'll take it downstairs and build it. That was a bad idea because one of these is a dresser. So I can't do it in here. But let's get off that topic. But yeah. Okay. So yeah, there's other stuff going on, CG, but not rocket related. And it's impairing me.
So that's what we've been up to. Nice little long show for you. So, but it was a great one, I think. I had fun with this episode.
I did too. I learned a lot. We learned a lot, guys.
And don't forget to check out the Noobs show, TheRocketryShow.com. And if you want to hear more of Gary, if you haven't heard it or you forgot about the Model Rocket Show, Gary Rosenfield was on that a couple of episodes back, talking about the low power composites, the Q-jets and all that. So Gary gave just about an in-depth interview on that with Daniel for the Model Rocket folks, as he did with us with the high power stuff. So if you're wondering, at times he references, we got to keep it to high power, because I wanted to do that. I didn't want to duplicate what the noob had. So there's like a whole nother interview chock full of info that's not duplicated on this one. That's from Gary on the Model Rocket Show. So check that out with the Rocket Noob.
I love listening to the Model Rocket Show, and Noob's got all the good questions for all the guests. It's fun. I like listening to it as well as this one. So I want to be a guest on that show. PG. we need to talk to Noob. I don't know what I talk about yet, so maybe I should level 3 first.
That's funny. Yeah. So check out the Model Rocket. He's got another episode that's in production, and so it should be coming out in a little bit. So it's another cool one for you there. So once again, the Model Rocket Show with the Rocket Noob. If you haven't heard of it before, go and catch yourself up. So there's more for you to listen to after you're done listening to this one. So still have great episodes on the way. I believe we're going to be talking to one of the local to Jeem and I contest clubs on the next episode on the Akron Akronauts, Akron University of Akron. So that's going to be fun. So they're excited about being on the show. We're excited about having them on the show. They are one of the local teams that I've been dying to get on and start following what they do. So they tend to compete in the NASA Student Launch Initiative. So we're going to talk about how their NASA Student Launch Initiative competition went for them and things they've learned. And we'll talk about what they can talk about for this coming year. So it's going to be fun. Another fun episode. That's the next Rocketry show. So, on that note, what's your closing, Jesse?
I don't have one.
There you go. I see model rockets.
I see model rockets. You know what? I'm gonna keep it. I'm gonna keep it real, guys. Keep your eyes in the skies. I'm gonna go that. Thank you, Jim.
We're going to see you next time on The Rocketry Show at TheRocketryShow.com. Have a great one and stay safe.
Have a comment? We'd love to hear it. Send them to mailbag@TheRocketryShow.com. If you enjoyed what you heard, don't forget to check out our sister show, TheModelRocketShow.com. The Model Rocket Show is hosted by the Rocket Noob and is all about low to mid-power rocketry. TheModelRocketShow.com with Daniel, the Rocket Noob. Check it out today. The views and opinions expressed on these programs are those of the participants and do not necessarily reflect those of Little Beth Entertainment or its sponsors.